Welcome back. So today we will see what is lock and why it is used in a threading type of process. Okay. Suppose there will be a process. Okay. Process P. It has a two thread T1 and T2, and they share some resource. Okay. Some resource. So how will this happen? Let's suppose that there will be a two thread created T1 and T2. Their work is to go to a function f and run a for loop for 1000 times, in which you have to increase the count value to count plus 1 and return the value. Okay, or you can say print the value. So what do you think after running the thread T1 and T2, means after completing the thread T1 and T2, what will be the value of count? It is 1000 or 2000. So T1 run the count and it take it to the 1000. Suppose the T1 first get the chance, then T2 run it for 1000 more time and take it to the 2000. So the final value will be the 2000. But when you run this function, you will get to know that the actual answer will become around 1900 something or 1900, this type of value. The actual value is something less than the real value. Why it will happen? Because of these two threads are not mutually exclusive to each other. What does it mean? And to make the mutual exclusive, we use lock. So why this happen? Let us explain with a chart. Suppose you start the value count is equal to 0. You have a two thread T1 and T2. So how will the thread work? Thread get the function, it increase the value, okay, save it to the temporary variable and then copy to the count function. Okay, this is how the function happen. Okay, it increase the value, save into the temporary variable, then count, copy the value of temporary variable. Suppose first T1 get the CPU and it increase the value up to the count of 100. Okay, now after this, suppose the count take the next loop and save the variable into a temporary variable, and before saving into the count variable, there will be occur a context switch occur. So here what will happen? A loop run, its value get increased, save in the temporary variable, but the count variable does not get its value, and before getting that thing, context switch occur. Okay, so again after context switch, this process get executed, and this time T2 get the CPU. Okay, so what will T2 do? T2 increase the value from 100 to 101 and save it to the count variable. And now suppose again the context switch occur. So here what will happen? That T1 does not know that its one loop get running, its value get saved in temporary variable, it again rewrite that value of 101 rather than writing the value of 102. So there will be a difference of one value in spite of running the loop. This is happened because before saving the variable real value in the count variable, context switch occur and the T2 get the chances. So here there will be no mutual exclusivity between these two, and they will independently increasing its own value of T1 or T2 without knowing that the one may increase the value but it does not get saved, and this condition is called race condition. Race condition is in which condition each thread increase value independent to each other without knowing each other, and this condition occur when the contexts which occur in a critical section. What is critical section? Here in this condition, critical section is increasing value, which is count is equal to count plus 1. Count plus 1. So how will we achieve this mutual exclusivity so that no two thread independently increase its value? We can achieve it with the help of mutually exclusivity, in which what we will do, if one function, one thread has a function of critical section, okay, that is count is equal to count plus 1, then the other thread cannot accept that critical function. What will happen? When one thread has a critical section, other thread cannot access the critical section, because if the other thread access the critical section before completing the critical section of one thread, then there will be the condition of race, which I told you. So how will you achieve this? You can achieve this with the help of locks. What will be you do? When one section, one thread have taken a critical section, what will it do? It will lock that critical section, okay? And when the next section, next thread T2 come and see that the critical section is locked, it will wait until the critical section will be not available. So what will happen? T1 come, first lock the critical section, complete its work, that is count is equal to count plus 1, okay? Then make it available so that T2 when come and see it is available, then it increases value, okay? I hope you understand it, how the lock work. Lock basically lock the critical section and it will be locked till the one thread does not complete its whole critical section. So how will you achieve lock? During the running of loop, this I say you, during a running of any loop, this is a function, you run a loop, okay, here you run a loop, okay. Before starting the critical section, you what will you do? You set the lock is equal to lock acquire, okay, and after completing the critical section, you set lock release. Lock release. You can get the log library from the Python function. Python library, you have a log library, so you do not worry about that. Okay, I hope you understand it. Before accessing any thread, before accessing the critical section, you have to log the critical section. After completing the whole work, you will release the log section so that that critical section is available for another thread. You said everything is very fine, but this log has its own disadvantage. What are the disadvantages? First one is contention. Contention means when T1 acquire any critical section, T2 had to wait and check each and every time for the critical section to be available. He had to wait, and this will be the wastage of CPU cycle, okay. Second one is the debugging. If you have a process which has a log, then the debugging becomes very difficult, okay. Third one is starvation. What is starvation? Starvation means, suppose there are two threads T1 and T2. T1 has a low priority thread, T2 has a high priority thread. Now T1 lock the critical section. Then the high priority thread had to wait until the T1 does not available the critical section. So here there will be, this condition is called starvation. Another condition which is very important, and I complete it in a detailed way, that is called deadlock. What is deadlock? Suppose T1 wanted a resource R1 that is locked by T2 thread, okay. Now T2 wants a resource that is R2 that is locked by T1. So it is a deadlock condition. Why? T1 want R1 so that it complete its work, to release the R2, and R2 want R1 so that it completes its work to release R2. In this condition, neither of them can complete its work and release each of them, and this condition is called deadlock. We will explore this condition very much in detail and how we'll solve this condition. I hope in this video you will be clear about what is lock, why we use it, and what are its disadvantages. We will take this thing in ahead about the deadlock and more topic in operating system. Till then, goodbye.